full view for this Shanghai Synchrotron Radiation Facility. So we will show you the images that we have taken. So we have a bird's view. So you can see the Shanghai light source is like a nautilus. So we can see this image on the Pudong New Area. And if you talk about nautilus, we will focus on and think of a very important novel. We have a submarine in the shape of a nautilus, and for a nautilus, it may show that people have the spirit of exploring the unknown. So we are very honored to have the opportunity to show you the inside of the Shanghai light source. So we have invited also a special guest. We have Professor Tian Feng, and please introduce yourself. Good morning. I'm Tian Feng, and I work with the experimental station of Shanghai Light Source, and today we will show you the Shanghai light source. And for a bird's view, we can see the shape of a nautilus. So you can see this model here. So we have this model for Shanghai Synchrotron Radiation Facility. So why the facility is in a circle shape? So it is a circle because we can see that by generating the light, we need a circle ring. And on that end, we will heat and generate the electron. After the electron is generated, we will inject it into a 180-meter booster, and the electron will gain the energy of 1.5 GeV, and then the electron will enter into the storage ring of 432 meter, and the electron will circulate near the speed of the light, and we will have the synchrotron radiation, and this radiation is very important for us to apply to the studies and researches. So you can see the spread for the electron, and we have the synchrotron radiation. It is like when we are using an umbrella, and if we turn the umbrella, we will have the raindrops spreading, and these raindrops are the synchrotron radiation we want to use. And if we talk about Shanghai light source, we will say it is a facility to generate light. So we will have the synchrotron radiation light. So what is it? And for the synchrotron radiation, it covers the light that we can see, that is visible light. But for Shanghai light source, we will choose hard and soft X-ray to undertake certain experiments. So these kind of rays cannot be seen. So we can see that for Shanghai light source, the light is synchrotron radiation. So if we put it into simpler terms, these kind of rays and lights are not visible, and the brightness is 100 billion times that of normal X-ray. So it is like a super microscopy. And with these rays and lights, we can see the microcosm. And for 1 millimeter, it is about 1/80th of a single hair. So for the synchrotron radiation, the definition may go even beyond millimeter. And with this synchrotron radiation, we can go to nanometer level. And later on, we can go even deeper in terms of the definition. And with this super microscopy, we can help the scientists to undertake their research from various aspects. So in this hall, we have introduced the basic information about the Shanghai light source. So now we will go inside this facility, and we will go outside the hall, and we will go through the path, and in front we can see there is an entrance. Normally, this facility is not open to the public, so today is a rare occasion. every year we will have 1 week of scientific studies, and the facility is open to the public. And so today is a very precious occasion. So for the scientists and researchers, what is your life like? So if you undertake the experiment, and if you maintain the facility, you can go into the facility. And these light sources operate 24 hours a day, so we can see the light beams continue to be generated. And we have advanced technologies. Previously, we have the regeneration of lights, and we can now have the 24-hour operation. You have mentioned about the operating hours for this equipment. So if you want to use the synchrotron radiation, you need to have an appointment. It is not so easy to have such an appointment. It is like you need to apply for this kind of time that you can use this synchrotron radiation, and we will have the evaluation based on the opinion for the experts, and then we can allocate the time for certain researchers to use this radiation. So if your project and study can use this synchrotron radiation, it means you gain the recognition by the experts. But the application need to be, say, half a year or even longer in advance to get the approval. And through various kind of evaluation, the scientists can gain access to such a synchrotron radiation. Only 1/3 of the applicants can get the access to this ray. So we can say for any scientists can undertake their experiment in this facility, they must be excellent in their study. And we go through one glass door, and then we enter into this light source. So we can have a view for the inside of this nautilus. So we are in a ring-like structure, and we are at one corner of this ring, and you can see we can go around this light source. So here for this experiment station, we have the scientists here, and he will close the door, and we can close the door here, and outside he can operate. For this synchrotron light, it has radiation, so we have a complete separation for the experiment and the outside environment. And we will have the control on the computer outside this kind of experiment laboratory. So we can see the doors closing. So we have this reminder warning the radiation. So for this synchrotron radiation, it will have certain kind of radiation. So for normal people to enter into the laboratory, normal people cannot enter into this experiment laboratory. It is like when you go to a hospital, if you take an X-ray, if you take so many times, it is not good for your health. And for Shanghai light source, the energy is far higher than that in a normal hospital. So for a normal human being, he could not stay within this laboratory. So there is a small fish inside the laboratory once, and after the experiment, the fish went dry. So for human being, he could not stay in this laboratory. So we need to separate human being and this kind of actual area for experiment. So it is rather telling if you compare that with an X-ray in a hospital. But we can understand that for the synchrotron radiation, the energy is far higher than that of an X-ray. And you can see the ring-like shape. For Shanghai light source, it has this kind of ring-like shape. So we can follow this path. And for such a laboratory, we have a lot of equipment, and outside space is also a part of this operation. So for a laboratory, it is just a long string. And we will have three parts. For the first section, we will have the optical component, so we can choose and filter the lights. And later on, we will have the experiment area where we need to put the samples, so the light will be directed to the samples. And we will have also a detector to gather the signal. And later on, we have the area for the scientists to stay. So it is a long distance control, so we can gather the information from the actual sample to this control portal, control computers. So we can see the scientists are just watching the experiment. So they are actually observing the results of the experiment. So for these days, I think that the scene is not the same as what we imagine. For a normal laboratory, we will think we will add different kind of components, different kind of elements, and people may seem so nervous. But here we can see the scientists, they are so calm. They just sit quietly here to observe. Yes, you have a good point. So we have the long distance control through computer. And previously, the scientists will put the sample in, and by outside operation, we just control the light to control the simple process. And the scientists want to see the signal gathered by the detector, and they will compare whether the data gathered are as expected. So we want to see what are the current experiments. So what are you actually observing? Would you introduce to us? So we are analyzing a protein structure from a micro level to observe what a protein looks like. And can we see the image of your ongoing experiment? We will gather certain data, and we will use different methods through biophysics to analyze the data. If you want to see a vivid image, we will need a certain software to analyze this data and to build a model or build the image. So for such an image, we see now what is it like. It is based on the data that we gather, and we have the crystal here, and the crystal now we are observing is not that good. And as a result, it's not published, so we cannot talk so much about it. But may I ask that for such an experiment, it is to observe a protein structure. So for such a kind of operation, what are the possible research fields? So we focus on protein and crystallization. And after that, we can observe the structure of the protein, the molecular structure. And we can use that to analyze certain viruses, such as Ebola, SARS, and other epidemic diseases. So we can analyze this kind of virus in these years, we have the eruption of certain viruses, and Shanghai Light Source has taken various tasks to have a research for different kind of viruses such as Ebola, Zika, and bird flu. So what are the previous researches like for such viruses conducted by Shanghai Light Source? For SARS virus, it is very difficult to analyze because we find that there are several different kind of structure for the SARS virus. And we have 3 structures, and these structures are constantly changing. And previously, if we do not have such a high-definition observation, we think there were just one structure, and we can offer these various kind of structures to the pharmaceutical professionals, and they can find out new drugs to deal with such a virus. So for Shanghai Light Source, it has an advanced study in terms of the virus analysis. And we have one room after another, one laboratory after another. So it is like you are turning an umbrella along the tangent line. We can see this light, and for one tangent line, we have one laboratory, and we have passed different kind of laboratories, and now we have 15 beam lines, and we will have more than 10 laboratories here. And 10 years before, where we stand was just a crop field. So today is the 10th anniversary for this facility. So we can see we have started from scratch, from bare field to such a scale. So when the facility was built for Nature, the top magazine for science has this kind of observation that China has entered into the top league for the scientific research. And for Shanghai Synchrotron Radiation Facility to be built, many scientists, they do not need to go abroad for certain experiments. Previously, scientists needed to go abroad to have access to certain facility. These scientists needed to go to Japan for the 3rd generation synchrotron radiation. And now the scientists can apply and go to Shanghai Light Source, and at the earliest juncture, the scientist can have the data. For a certain sample, there is a time limit, so the scientist can apply for a urgent processing and urgent application. So if you do not have access to Shanghai Light Source, it is time-consuming because you need to go through the visa procedure, the approval procedure. Previously, scientists needed to go to the US or Japan, and it is time-consuming and effort-consuming. So with Shanghai Light Source, domestic scientists can use this facility for their experiments. And if you use the foreign light source, the application is also complicated. So domestically, if we have access to Shanghai facility, it is really good for scientists. And we now enter into another laboratory, so we can observe what are the possible experiments here. So we focus on the experiment here. The volume for the light is very small, so we can have different kind of scanning. I'm from China Academy of Science. I'm studying material sciences, and we focus on the rice element, and we can see the iron and other element when they enter into our body. We want to focus on its interaction with human organs. We focus on nano element actually. We focus on magnetic resonance. We focus on the interaction with the cancer cell, and will this magnetic resonance have any influence on the cell surface? So for such an image, what you have observed, so for such a circle, it represents a cell. So you can observe each cell. We can see different and changes of these elements among different cells. So we can understand that whether the imaging device will have a positive or negative influence on human body. Before, it was difficult to have such an observation. A nanomaterial single cell of a tumor. So we can only get certain keywords because it is so complex for a green hand like I am. And for the ordinary people, maybe we cannot understand so deep knowledge, and what happened here may be beyond our grasp. But I think these kind of experiments are important. Yes, it is important. And later on, we can go to another experiment station, and this experiment station may be even closer to people's daily lives. And would you introduce to us? We focus on nanometer material, and this material is conducive for the research on tumor treatment. Is it true that by undertaking this kind of research, we can have better treatment for tumor? Yeah, why for this station we can have such an experiment? We can see the beamline is very small, and for this kind of nanometer material, once it enters into the vein, we can use this small beamline to observe the performance of such a material. And for this experiment station, the beamline was about nanometer level, and it is possible to use such a high-definition observation to have a better understanding for this kind of nanometer material as well as its interaction with the cancer cell. You have also said that the light source keeps operating 24 hours a day, and for the hours here, it is difficult to apply. So if you have the access to use the light source at night, it is even a precious chance. So the scientists work very hard to make the full use of the access and to get this kind of data. So we have this kind of information that this facility has opened for 10 years, and each year the operation hour is 7,000 hours each year, and the demand is so strong. The application for hours is about 3 to 4 times our possible facility capacity. So for the whole 10 years period, the Shanghai light source has helped about 13,000 research projects, and 518 institutions have used this light source, including universities, research institutes, and companies. And we have 41,000 personnel using this facility. And we know that for the past 10 years, Shanghai light source has become the scientific equipment with the largest users. So is this facility playing a fundamental role in terms of the basic science research? It is very important here. We can see for this experiment station, it is closely related to the Belt and Road Initiative. Once we go abroad, we help the foreign countries to build the express railway. And for this experiment station, it can research on the technology for high-speed railway. So this is biomedical imaging. We use this synchrotron radiation so we can have higher definition and clearer view. And here we can also see for the environment application and application in physics. And for the first time, we can see the image for birds even during the dinosaur age. And the earliest dinosaur is even as small as a fist. And we can discover this kind of fossil. And if we cut the fossil, we cannot maintain such a complete image. And we use this synchrotron radiation, we need not damage this fossil, and we can observe the inner structure. So we can see it is not a bird, it is actually the smallest dinosaur. And the earliest dinosaur actually came from bird. So first a discovery, it is very important for us to believe in such a proposition that actually dinosaurs come from birds. And you can also, we have a video and a slide here, so we can see this kind of application. So while we are trying to find the video and slides, we will talk about the application for this facility. It is a interdisciplinary research platform. It focuses on bioscience as well as material science, chemical services, environmental protection, as well as geoscience. We can see this facility can offer the services and light to scientists. So for this experiment station, you can see we have a mouse here. And this experiment station focuses on mice, and we use them to replace human organs for certain experiment. And as for mice, we can say there may be tumor, and we can observe the structure of the tumor, analyze how the tumor come into being, and at the very late stage, we will go to the human being. But this X-ray is too strong. So how can we observe the internal organ structure without damaging human body? This is what we need to discuss. And this is altiplano. The grasshopper living on altiplano. So we can see the grasshopper is tied to this plate, and we have this X-ray, and we can see very clearly how this grasshopper breathes. And after the experiment, the grasshopper even survive. And despite the grasshopper being alive, we need also get rid of it because we do not know the result for the radiation, so we cannot let it out. So the imaging is closely related to this special kind of ray, this synchrotron radiation. And now we can see this experiment is related to the high-speed railway. So we can see the growth process for the different crystal, the alloy. So we can see the structure for the material. So we can see how the alloy grow, and we can get different kind of data. And through this kind of experiment, we have a professor from Dalian Institute of Technology. He has won a second award for the National Scientific Progress based on this analysis of alloy. And we can see how the salt will influence hypertension. And we can observe the influence on the vein. And we can observe the influence of salt on hypertension because we can observe the vein. And we can have the angiogenesis analysis. So we have tumor treatment. And we can have early detection for tumor, and it helps us to prolong people's lives. And we have the ancient embryo fossil. So it is very difficult to find another fossil, so we cannot damage this fossil. So we use X-ray to observe the internal structure. So we can have this three-dimensional observation. And this is very accurate, and it goes to the full capacity of this experiment station. And we can even go further with new experiment station to the nanometer level, and we can know more details about this fossil. So we now observe the detail, and we can get certain major achievements. And thank you for sharing with us the achievements. And for this, we can understand the profoundness of these kind of studies. We know that even for certain researchers that common people cannot understand, we can see these studies are really important. We know that for Shanghai light source, it has been 10 years with various kind of achievements. For the past 10 years, about 5,000 papers have been published. And in Nature, Science and Cell, these top international magazines, the papers have been published in the month of 1996. So for such an achievement, it is outstanding, even nationwide and worldwide. And certain achievements have been incorporated into the 10 top scientific achievements in the US. And previously, we also say that we have the 10 top technology advances in China. We still have the achievements come from here. So we have such an achievement. In 2015, there was an Australian professor. He has analyzed the achievements thanks to certain light sources. And according to the Australian data, for Shanghai light source, the achievements have taken the first place in the world as compared to other light source facilities. So it is such an outstanding achievement. We can say before, the scientists needed to go abroad to find proper light, and for the 10 years of the Shanghai light source, it offers the opportunity for them to study and undertake the experiment domestically. And is Shanghai light source still open to foreign users? We plan to open to foreign users this year or next year. And maybe previously the foreign users will go through a Chinese partner to use this light source. And we will not exclude the foreign users if they go through the Chinese partner. We will ask them to be able to speak English, and it will not hamper our communication. As long as the foreign users can satisfy this requirement, it is okay. And for Shanghai light source, we need to open to the world. And this is also an important step. And we can say Shanghai light source is a symbol for China, and we need to be internationalized. We need to go global. About more than 10 or 20 foreign users have been here to use this light. And it shows that Shanghai light source is no inferior to foreign sources. Otherwise, the foreign scientists would not go to China. And we now enter into another experiment station. It seems so sophisticated for such an equipment. So this is a new laboratory. We may discuss with them. So may I ask, what kind of experiment are you doing here? Would you introduce your experiment? So here, we can have the actual scientists here. Would you introduce what are you doing for these experiments? We have two equipment here. We focus on photoelectron spectrum. And your equipment seems so sophisticated. And these are fine equipment, and they may look so difficult to operate on. And we have more additional functions. And these equipment seem larger. And would you explain what you are doing in simpler terms? And we will focus on the common users. Many users are curious that whether we can use X-ray to have a certain imaging. So we have the analysis for the magnetic performance, and some users are curious about chemical performance. We can have XPS. We can observe the elements and distribution of elements. And we can have the image for a different dimensional element. So this experiment station is called a dreamline. A dreamline. Why is it called a dreamline? So it is actually under the purview of the Shanghai Institute of Physics. And we have 3 institutions participating in this dreamline. And through this line, we hope that we can use Shanghai light source to build a laboratory that is world-class. So why we call it a dreamline, it is because we want to lead the world. Are there any dreamlike achievements? We have many achievements. And we have the achievement, which has been recognized as one of the 10 major advances across the world. And this has also been reported by CCTV. So would you introduce about this achievement? We have discovered a new particle. It is actually a completely new particle. So we will. I cannot talk so much in detail. And for this particle, it has been expected for so long. And we have Welfing as the scientist. And in this Shanghai light source experiment, we have discovered this particle. And through this kind of equipment, we have detected this particle. And in our report, for this kind of particle, we say that it is the first time for a Chinese scientist to discover a particle. And in my memory, I think we have been reporting it by CCTV. And we can now see that on this streamline, we have various kind of achievements. And we will summarize what we see here. We have visited 3 to 4 experiment stations. So for the application here, for the Shanghai Synchrotron Radiation Facility, we can apply this facility to the research for bird flu, Ebola, Zika, SARS virus analysis. And this is also beneficial for the prevention of epidemic diseases all across the world. And we have the observation for human genes, and this has been incorporated as one of the 10 major scientific advances by Nature magazine. And we have nanometer material, and we have the ultra-conducting material, semiconductor material, and other kind of materials. And in this respect, we have substantial achievements. And if you focus on material, we will have another achievement for carbon fiber. Carbon fiber is closely related to Shenzhou 5 and Shenzhou 6. And this carbon fiber is a very strong fiber. But China will still lag behind. Previously, we expected the gap to be 20 years. And previously, the Chinese scientists have dedicated 10 years to solve this issue, to keep up with this gap. And in Japan and the US, back then, the strength should be T1000, and this kind of gap was made up for in Shanghai light source. We can observe where we lag behind using the light here. And for the carbon fiber, we can match the domestically produced carbon fiber can achieve T1000. And we will also need to work hard to keep pace with international level. But now we can achieve the strength of T1000, and this is actually sufficient for us to launch a satellite using domestically produced carbon fiber. So Professor Tian has talked about the study in terms of material. And we have the international competition in China. We have achieved T1000, and in Japan, now the figure is T1200. So this kind of competition, and there is no limit to scientific study. And in bioscience and other sphere, we have the application and study in terms of the fossil as well as for the stroke study as well as other bone framework. We can have these kind of applications also. And we can also apply the light to the development of new drugs. So in addition to what we have mentioned, a lot of enterprises also want to gain access to Shanghai light source. And I will give you an example, the pharmaceutical companies. All across globe, out of the 10 big pharmaceutical companies, Pfizer and other big pharmaceutical companies, they have used Shanghai light source. And for them to use the Shanghai light source, they will spend a lot. And we can say these large companies want to gain access to Shanghai light source. They will buy the hour to do the testing, and we can say they are making a large investment. For domestic university and scientific institute, if they want to do the study, we will exempt the fee. But for large companies, we will charge the fee. We will actually say that this kind of Shanghai Synchrotron Radiation Facility, we have a tight control on the fees. But for the large companies, they will spend about 2,000 per hour for using the equipment. We totally have a fee-free operation if the domestic institutions want to use the Shanghai light source for study, for research. So at last, we will look forward to the future because we think that Shanghai light source, we are still in the maintenance and decoration process. And now, Shanghai light source is experiencing a kind of renovation and maintenance. We are called the third generation synchrotron radiation. And if we talk about the underground maintenance, we have the X-ray electron laser equipment. And with this upgrading, we have another soft X-ray facility, and this kind of upgrading focus on free electron laser. And for the underground upgrading, it focuses on hard X-ray. It is the equipment with the largest amount of investment. And the study focus on this kind of railway application. As you have mentioned, we have various kind of upgrading here. And for the second phase of Shanghai light source, it is still undergoing, and by 2020, we will finish the second phase of Shanghai light source. And a part of the experiment station will be finished by 2021. So for phase 2, what are the expected upgrading? I will give you one example. The phase 1 experiment station will be close to the ring. And for phase 2, we have USUCs, and we can go outside. So we need a long distance. So I will give you the data. For now, the spread experiment station, we will have 1 to 100 nanometer. And for the future station, we will have the range from 1 to 1,000 nanometer. So for such a range, it is very important for certain scientists from 100 to 1,000 nanometer. This kind of equipment is so rare. And from 100 to 1,000 nanometer observation, it is so difficult previously. And so for this new upgrading, we make up for this previous gap. It can offer substantial help for the scientists for their observation. And the new experiment station will have higher strength and we will have high-speed experiment. And for the tire of airplane to take off, it is 30 meters per second for the friction. And for such a high-speed experiment, we need to have higher strength of the light so that we can observe the changes in the material and in the structure. So we will use the phase 2 facility to observe the high-speed experiment. So for the 2.0 of Shanghai Synchrotron Radiation Facility, we will look forward to this higher performance. And by 2022, we will have 35 beamline and we will have 60 experiment stations. And by that time, the SSRF can take 10,000 users each year. And we can offer more access for the domestic and foreign users to do the experiment here. And currently, Shanghai light source is also have the upgrading for the soft and hard X-ray laser, and for this kind of equipment to be installed, we will have a research center for the photon research. And at the very end of this report, we will focus on the lives of the researchers here. And Kobe has mentioned that nobody knows what 4 a.m. looks like in Los Angeles. But I can have an analogy here. People may not know what the eclipse of Shanghai looks like, but the scientists, even at 4 a.m., they need to stay here for this kind of experiments. So at the very end of the report, thank you, Professor Tian, for visiting and introducing Shanghai Light Source, and we have our best wishes for the scientists and researchers to explore and to research here. So for Shanghai Light Source, it focuses on light and truth. So we can see this light source can bring more opportunity for us to seek the truth. So this is actually for today's program on the Shanghai Synchrotron Radiation Facility.